So we have scale drawings next, and this is again a part of geometric figures. And if you look at the learning target, I can use a ratio reasoning to find actual lengths and areas from a scale drawing and reproduce a scale drawing at a different scale. The vocabulary that you will learn over here: scale, scale drawings, scale factor, and scale models. Okay, so in the real world, when we look at scale drawings, the or scale models, because we see scale models also. Okay, these are used to represent objects that are too large or too small to be drawn or built at an actual size. So, when you see people designing the entire park in a tiny sheet of paper, or an entire mall, they've made a small model of what the actual mall will look like. That's nothing but a scale model, or the drawing of the park is a scale drawing. And so, because that is something too large to fit in that little teeny tiny paper, but we want a visual before we start doing the actual construction or design. All right, so that's what a scale drawing is, and that's for a large object. But sometimes the microscopic objects are also drawn so big that we can see what our eye cannot see without a microscope. We can as a drawing, because it is an enlarged version of the object. And so very often you'll see, for example, even small little bugs or something like flies, etc., they'll have been drawn so big so that you can study the parts and all that stuff. So that is nothing but a scaled drawing of an object which is too tiny, or in the earlier example that I gave you, and something which is too big. So something which is too large or too small, you can make scale drawings or scale models of those objects. And it represents the objects that are too large or too small to be drawn or built at an actual size. Okay, so the scale gives the ratio that so the scale, this is what gives the ratio of what compares the measurements of the drawing or model to the measurements of the real object. And the measurements on a drawing model are proportional to the measurements on the object. And you can use a scale drawing to find the actual length of an object or the actual distance between 2 points. So here's just an example. This is a little map over here, and in the map, you can see that the scale, all the maps normally that we follow, they always have a scale. So for example, this one, let's see here. So this scale is always given. And it's telling me that 1 unit is equal to 200 feet, okay, which is the actual amount, which is the 200 feet, but like 1 unit is representing that. Okay, so in this map, what we are trying to do, is we are trying to find the actual distance between 2 points. And what we're going to look at over here, what points are we looking at? We are going to look at the intersection, the distance from Bowman Road. Over here we have two. We have the Morehart Road and we have the Blair Road. This distance, okay? So I can like fit it on my smart board, but in reality, the entire road is not going to fit on that smart board, right? So this is definitely drawn to scale. That's what it means. And it's saying that 1 unit is equal to 200 feet. So this is 4 units over here, the intersection. So they're saying this distance is 4 units. So we can use calculations to figure out how many feet that will actually be. All right. So if I look at this, all right, this is the map over here. So it's saying 1 unit is 200 feet. 1 unit is 200 feet. Okay, here let me try to get this a little closer so you can see better. There we go. All right, 1 unit is 200 feet. And so this 1 unit is what is on the map. Okay, this is what's on the map. The 1 unit is on the map. And the 200 feet that they're talking about, this is the actual measurement. Okay, so that is the ratio that is provided. So we are going to scale it. And if now between these two, all right, so this is equal to now 4 units. And so we're going to make an equivalent ratio in order to calculate this. An equivalent ratio will help me know what the actual measurement is going to be. And so again, the 4 units is what? This is on the map. So what would the actual distance be? And in order to calculate this, all I'm going to do is 1 times 4 gives me 4. Whatever I do to the numerator, I'm going to do exactly the same thing to the denominator. And if I'm going to say 200 times 4, and so that gives me 800 feet. That gives me 800 feet is the distance between that. And so that's how I can calculate the actual distance based on a scale. Okay, so let's say, what if they tell me that what's a good scale to use for the scale drawing of the Eiffel Tower if the actual height of the tower is 324 meters? So if I have Eiffel Tower, I can always think about, okay, what scale can I use? And if it's 324 meters, I can basically say 1 centimeter is representing 10 meters, etc. So therefore, my calculation becomes a lot simpler when I am scaling it down. All right. Now, let's look at this now. And we are going to try to calculate the distance between these two cities. All right, so use the scale of the map to find the actual distance between Hagerstown and Annapolis. Okay, so let's see. And it's telling me that what is the scale given? I have 1 unit is equal to 24 miles. And so you will find this in every map or whatever that you see, the scale drawing, because a map is a scale drawing. You cannot fit the entire United States into a little whiteboard like this or entire city like this, unless of course it's a scaled down version. So just think about it. Okay, the entire country fitting in my classroom, that would be something else. Okay, doesn't work like that. And so that is why we have the scaled down model, and every map is nothing but a scale drawing of the larger representation. So if I have this, now it's asking to use the scale of the map to find the actual distance between Hagerstown and Annapolis. So we can see that the distance between the two cities on the map is 4 units. Okay. And so now what we are going to do is we are going to talk about what is the measurement on the map to the real amount. And so we can write this down using equivalent ratios. And so let's see, it's saying 1 unit, this is on the map, is equal to 24 miles, and this is actual. All right, so 1 unit is 24 miles. So therefore, what would this length or the distance be if I am looking at 4 units? How much would this be? So now this one again, this is on the map. So 1 times 4 gives me 4, right? And so then we are going to see if 1 times 4 gives me 4, 24 times 4, because again, whatever I do to the numerator, I have got to do exactly the same thing to the denominator. So if that is times 4, I have got to multiply the denominator by 4 also. And I get 96 miles is that distance from Hagerstown to Annapolis. And that's how we calculate the actual distance using a scale drawing. Okay, so to create scale drawings, I'm just going to show you up here. Okay, so let's look at this. In order to create scale drawings, let's say we have something given to us, you're creating the scale drawing of a room, okay? And you've been given the length and the width of the room. You've been given the length and the width of the bed and the dresser. And now, as you can see, this is in feet. Okay, so how can we fit this on a paper? So basically what we do is we are going to be doing a scaled down version. All right, in this case, and we choose a scale that is going to work. Hold on. So look. So we can basically say that 5/10 foot is the, here. We are drawing the bed, we're drawing the dresser, and we're choosing a scale for the drawing to convert each measurement using the scale. And on grid paper, we use the scale to draw the measurements. And we can say 1 unit, so this 1 unit over here on the grid paper equals 5/10 foot of actual length. Okay, so if 1 unit is 5/10, 2 units is going to be 1. And this is 2, and this is 3.5. So look, 3.5. Okay, and then we can do it this way. This is 5/10, 1, 2, 3, 4, 5, 6.5. And so it is representing each of this tiny line over here. It is representing 1 unit, and that is going to be is representing 5/10 foot of the actual length. And this is definitely not 1 foot when I look at this, because 1 foot is the what, 12 inches, right? So that is why this is just a scaled down version of these actual measurements. And that's how we design rooms, and where to put the windows, where to put the furniture, the interior decoration. So all this is done in that manner. Okay, this is just not cooperating today. Let's see. Yep. Okay. So let's look at this one here. Using scale drawings to find the actual area of a space. So first we are going to write an equation, but here, let me try to pull this down. This is just not behaving today. All right, so let's look at this. All right, so we've got the drawing shows the map of a restaurant drawn to scale. On the map, as you can see, 1 inch is representing 5 feet. What is the actual area of the kitchen? The kitchen is a rectangle. To find the area of the kitchen, just find the length and width of the kitchen, honestly, right? So it's telling me that 1 inch is 5 feet. And what would be the area of the kitchen? Okay, so in order to do that, all I'm going to do is it's telling me that, okay, so here's the kitchen part that we have, all right, and it's telling me that 1 inch is equal to 5 feet. So what would the actual measure be for the length of the kitchen? So what I'm going to do over here, I'm going to write 1 inch. 1 inch is 5 feet. So if I have 9 inches, look, if I have this part, 9 inches, how many feet would that be? So in order for me to find that, all I'm doing is 1 times 9 Okay. So 1 time 9, and so then 5 feet times 9, because whatever I do to the numerator, I do the same thing to the denominator. The actual length is going to be 45 feet because 5 times 9 is 45. So that's how I find the actual length. Then I'm going to find the actual width. And for width, same thing, I have 1 inch is equal to 5 feet. So let's see, what is the width here? Okay, so the width is what? 5 inches. So if I have 5 inches, how many feet would that be? So 1 times 5 gives me 5. Same thing to the denominator, times 5, and I get 25 feet. And I get 25 feet. So what is the area of a rectangle? Area of a rectangle is length times width, because that's what we're trying to find. What is the area of the actual kitchen? And now that I've found the actual measurements, all I'm doing is length times width in order to find the area of the kitchen. So the length of the kitchen was 45, which we found over here, 45 feet. And the width that I found was 25 feet. And so 45 times 25, I am going to get 1,125 square feet. And that is the area of this kitchen in square feet, the actual area of the kitchen in square feet. And that's how we do these calculations. Let's do another example on this. And okay, let's do another example. All right, here is a scale drawing. The scale of the floor plan is 1 inch is equal to 3 feet. And what is the actual area of bedroom 3? So bedroom 3 is down here. So I'm going to pull this down. Hold on. Hope this cooperates. Okay, there's bedroom 3. Okay, so we're trying to find the area of bedroom 3 now. And so first I have to look at what is the scale. It's saying 1 inch is 3 feet. Okay, and so I am going to highlight bedroom 3. Okay, here is, come on. Okay, here is bedroom 3. And we are trying to find the actual measure of bedroom 3. Okay, so to find the actual length, what do I do? First, I say that 1 inch is 3. What was the measurement given to me? Was 1 inch is equal to 3 feet, and that's what the measurement was provided earlier, the scale. All right, and so now when I look at the length and the width, I'm going to try to find the length of this, and the length is how much? 4.5. Okay, so 4.5 inches is equal to how many feet? So all I'm doing is I am doing 1 times 4.5, and whatever I do to the numerator, I do the same thing to the denominator. And if I multiply 3 times 4.5, I am going to get 13.5 feet. Okay, so this is my measurement of the length. Length is this much. Now let's look at what the width is. Okay, width over here it's showing me as 3 inches. And so I'm going to go and repeat the same thing. I know that for the width I have over here I have 1 inch is 3 feet. So how many inches? This is what do we have here? We have 3 inches is how many feet? Okay, so 1 times 3 gives me 3. And again, whatever I do to the numerator, I do the same thing to the denominator. So times 3 and I get 9 feet. So now I have the actual measurements of the length and the width. And to find the area is length times width, which is, what was my length? I got 13 and 1/2 times the width, which is 9. And then when I multiply this, I am going to, I can also write 13 and 1/2 as what? 13 and 5/10, and that is perfectly fine. So if I wrote it as 13 and 5/10 instead of this, and you can do it both ways. I'm just trying to show you this is an option. So if I did 13 and 5/10 times 9, I would get 121 and 5/10 square feet. Square feet. And so this would be the actual area of bedroom 3 if we were doing those calculations. Okay. So artists use scale drawings to create wall murals. An artist might draw the mural on a piece of grid paper. Then he or she would draw a much larger grid on the wall before painting or drawing. And the mural, uh, before painting or drawing the mural, okay? So you can use a scale to reproduce a drawing that is similar to the original but a different size. So here is an example. So let's say I have something like this over here. So this is a drawing that we're trying to reproduce, a scale drawing, and the diagram represents a city park. The scale is 1 unit is 30 meters. Reproduce the drawing with a scale of 1 unit is equal to 10 meters. Okay, so we are going to look at this, and then the width of the drawing, the length of the drawing of the park is how much? We have 4 units. Okay, so this is 1, 2, 3, 4. Right? So this is 4 units. And then if I look at the width, so this is 1, 2, 3, 4. That's 4 units. And if I look at the width, this is 1, and then we have half. So that's this is 0.5. Okay. Here, let me do that better. Okay. So this is 1, and then this is half. Let me write it like this so that you can see what I'm talking about. So total amount is how much? 1 and 1/2. Right? So the actual dimensions of the park are, we have 1 unit is 30 meters. That's what it's saying. So the actual dimensions of the park would be 4, because 4 times 30, and that would give me how much? That would give me 120 meters. Okay? And then the actual dimensions of this part, okay, that is going to give me how much? 1 and 5/10 times 30. All right, and so I get 45 meters. So this is the actual dimension right now. Now, using the new scale, we have 1 unit is equal to 10 meters. So this is my new scale. All right, so all I'm going to do is I am going to take the new drawing, and using the new scale of 1 unit is equal to 10 meters. The new drawing will have a length of 120 divided by this 10. Okay, because it's saying 1 unit is 10 meters, and that is going to give me, or this is going to be 12 units. Right? This is going to be 12 units. And the new drawing will have it. So this is my length. And then my width, again, I'm going to take, what did I have? I had 45 here. And I'm going to divide 45 by 10. And I'm going to get 4 and 5/10 units. So these are my new measurements. Okay. And so then based on this, let me show you what it's going to look like. So you're going to count the number of squares, and so this is what it's going to look like using the new dimensions. So to reproduce a scale drawing, use the grid to count the number of squares for the length and width of the original drawing. Use the new scale to find the length and width of the new drawing and create the new drawing on the grid. Okay, counting the squares for the new length and width. So we had just done how we have 12 units and 4.5 units. So using that, this was created for this park. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look, and 1, 2, 3, 4.5. Okay, so that's how scale drawings are created. And so anything that is too large or it is too small, scale drawings are created so that we can fit that on paper and have use your ratio reasoning to find equivalent ratios in order to be able to draw the material or create models of these large or small objects. All right. Have a great day, everyone.